about with you. Okay, screen. Okay, Ahsan, can you hear me?
Yes, Hujam.
And you can see the screen, right?
Yeah, Hujam.
Okay, so why don't you all do this question? Let me decrease the brightness of good. So for this question, you have to again talk about okay, let me put this way. We have said hello Hazar. We have said that beam bending is included, right, for our exam. So let me put this way. This is complicated, right? So let me put this way. Something like this. These are all, of course, coming in exam. We already know, but something like this for midterm 1, I think it will be a little complicated because you don't have too much time to practice. So I will definitely give you beam bending problems, the bending stresses and everything. But a problem like this, for example, is not coming. Okay. Are you understanding me? So for example, you know what is the centroid of this, right? You know what is the, if I have to, let's say, bend it like this. Okay. If I have to, let's say, bend by putting a force like this. So this object will, how will it bend if this is cantilever? Like that. Okay. Do you know the centroid of this? You know. But for object like this, you have to find the centroid and neutral axis. So it's complicated. So simple problems are definitely coming for your midterm 1. A problem like this is not coming. A problem like this, I mean, this problem. These are definitely coming, of course. These are coming. Let me put lots and lots of text, but problems like these are not coming. Okay. Okay, do it. What is the number one step? The number one step is that you need to know in which direction the force is being applied. So let me tell you that the force is being applied in this direction. If the force is being applied in this direction, then what is the beam? Let's say this is your beam. Are you following me? And let's say this is a simply supported beam. So simply supported, doesn't matter simply supported or not, but I am trying to tell you if it's simply supported. So let's say from the side view, you have object like this. How will it bend? It will bend like this, correct? So please focus on this yellow structure, this little thing I have created. So if it is bending like this, the question says that for a moment of hang on. The moment was given in the question, wasn't it? Yes, no? Moment is that's bizarre. Anyways, let's say mz is given. I don't know the value right now. I will find in my notes. So what is the number one step? Good. Number one step is find the neutral axis. But in order to find the neutral axis, it means that you have to find the centroid. So the formula of centroid is y prime equal to summation y I a I over summation. Very nice, everyone. Okay, now you have to find by making this little box how many agree. Number one, number two. So this structure you have to convert it into rectangles yourself. I converted this rectangle and the big rectangle. If you don't like this, you want to make this as big rectangle and this as another rectangle and this as another big rectangle, you are allowed to do it. But I actually somehow made this as the big chunk and this as another chunk and this as another chunk. So my first rectangle is this one. My second rectangle is this one and this one. Number one, number two. So first thing is yi, then I have ai, then I have product of yi, ai. So now you can solve the question yourself. So for number one, it will be, I suppose in order to find this, I have to, I suppose, make a reference line, no? So I am making my reference line here. Students who don't like this and want to make their reference line here, they are allowed. Students who want to make their reference line here, they are allowed. You can make reference line anywhere. So yi is 1 over 2 h1 ai, you have to do it yourself. And then similarly, you have to find the yi of this one. Do it. No? Yes. Let me help you then. What is the yi for this rectangle? It will be 1 over 2 b2 plus 1 over 2 b2 plus that h1 will take it to the reference line, the blue line. Okay, I think this is still new for everyone, so I think I have to do it first. It's not clear. Finding the centroid of these complicated structures, I think, was taught to you somewhere, but 1 over 2 b2 plus the reference line is how much distance apart? h1. Then ai is easy, it is b1 h1. And this is also easy, it is 2 b2 h2. And then yi ai, you will use the calculator yourself. I'm definitely not doing. Then you will use y bar equal to the formula and give me the answer in millimeters. And this centroid will be y bar from which line? The reference line that you have created. Now, last but not least, this means that the neutral axis passes through which line? The centroidal line that you have found. So find it yourself. Then in the meantime, I will write the formula for students. Stress X is equal to minus mzy over iz. And you have to find the iz, I suppose. So students who are getting confused by x's, this is y, this is z. This is y, this is z, and this is x. Okay. So in this way, you can find ice. Let's make a rectangle. Is this even clear? Everyone, no? Yes. Really? Okay. So now you will find the I value. How? Number one, number two, and it's a little hard, I suppose. This is IC. This is D. This is moment of inertia about the Z axis. That is your neutral axis. Then you will find the IC, which is 1 over 12 B 1 H 1 power 3. And then you find your IC here as 1 over 12 B2 H2 power 3. And just find these two little chunks and then you have to add it. We are not going anywhere in terms of progressing in the course, I mean, for another 5 minutes. Take your time. Where did my pen go? Oh, I think my pen went somewhere. Oh. Ehsan, Sadek, and we have Dogu Khan. Please ask me questions. Give me the Y bar, quickly. Y bar. 53.41. Okay, good. His answer is right. I have already double checked. 53.25 is in my notes. Whatever, that's fine. 53 point. Okay, now also give me these chunks. How will you give me these chunks? So, okay, let me help you.
Is the distance of the centroid of the object to the neutral line?
From the centroid of the individual chunk to the neutral line or the centroidal line. Very nice. So let me actually help everyone. This is B2. B2 dimension is 150. So I have 75 millimeter here, and I have to go from here all the way up to the centroidal line. Now my centroidal line is, as you said, 53.25 millimeter. So this is 53.25 millimeter from my blue reference line. So if this is 75 millimeter and this distance is 25, then this means that 75 plus 25 is 100 millimeter from here to here. So 100 minus 53.25 will give me 43.75. Salam, 43 point. This seems very confusing. Look. You're trying to find the moment of inertia of the individual rectangles, like individual components. And then at the end of the day, you have to use parallel axis theorem, right? Although 12 BH cube plus AD square. That D is that fellow. So for the individual rectangle, I have got 1/12 BH cube, but then I have to add that little AD square, because at the end of the day, moment of inertia of every bit will be about the neutral axis. Why on earth I am trying to find the moment of inertia about its own axis, like the little rectangle? Come on, little rectangle has no value for me. At the end of the day, the value is about the neutral axis, which is this one. Everyone, this one. Look. You see this purple line? This purple line is where you have to find the moment of inertia of all the rectangles. So moment of inertia of this rectangle about its own center is 1/12 BH cube. Then I did a AD square. What is this D? This little distance is 43.75. So doing a plus AD square will help me find the moment of inertia of this chunk about this line, which is the neutral axis line, which I have already found. So focus on the purple line. Okay, then give me these two values then.
While finding the moment of inertia of the second part.
If
there is 2, shouldn't we multiply with 2?
Good. So very good. We will multiply with the 2. He's right. So we will do a 2 multiply by whatever you find. Very nice. So are you doing it? No? Yes. No one is using calculator today. Okay, I have the values, but I wanted you to just use a calculator. 1/12 B2 is to 2. Do it. Do it. Calculator. Do a 1/12 B2 is to 2. Okay. No one is doing today. I have already made the announcement, by the way, for the exam and stuff in the initial 1-2 minutes. So you have to watch the recording if anyone can read. It's not confusing. You have to find the moment of inertia of the whole structure or of the whole cross section. It has 3 chunks: left rectangle, right rectangle, top rectangle. In order to find the moment of inertia of the whole thing about the neutral axis line, I first find the moment of inertia of every rectangle about its own centroidal line. Then I add AD square, where D is the distance of that individual rectangular centroidal line to the centroidal line of the whole structure. It's confusing.
Sir, can I ask something? What does B stand for?
Parallel axis theorem. The distance, I just said, the distance of this rectangle centroidal line to the centroidal line of the whole structure of the whole cross section, which is this line. So this little thing is the D. Okay, what is the D for this rectangle? You can help me. What is the D for this rectangle? It will be the distance of its own centroidal line to this line, purple line. Okay, so we have 2 multiplied by 11.4 into 10 power 6. Nobody gave me the values. You got it?
No.
And this one is 11.8 into 10 power 6 in millimeter square. Millimeter power 4, I'm sorry. Yeah.
While calculating the second one's moment of inertia, we said IC. The B2 H2 cube. Which one is B2 and which one is H2?
This is B2. This is H2. Okay.
But-
This is B1.
Mhm.
This is H1.
But while calculating the moment of inertia with respect to the IZ, we need to do H times B2 cube, as I guess. Is that true?
No, I
Because
explained
the
that.
Z is towards there.
No,
and
no,
Y
this is-
towards up.
No. You're not getting my point. So if you see this whole thing is a beam like this,
Yes, absolutely.
load is applied like this, and this beam will bend like this, right?
Okay.
So if the beam is bending like this, so of course we have to find the IZ, right?
Yeah.
Look from here. This is your structure. So this thing will bend like this, no?
Uh-huh.
Like this, right? So where is the Z? The Z is towards the left.
Mhm.
So of course, the whole thing is curving like this. So I have to find IZ.
So finding the IZ,
We are finding IZ.
finding the IZ is, I guess, H2 times B2 cube divided by 12.
Oh, acha, okay, got it.
Because
Yes. Thank you. Very nice. Good. Very good, by the way. Thank you. I actually did not notice. I was very hurriedly, I put it like this. I appreciate it. Thank you. H2B. Excellent observation from him, by the way. I never thought that I had made a mistake. Sorry, it was in hurry. I think I made a mistake. Of course, H2B2 power. Thank you. Okay. So now that you have got this, you will put the values 2 multiplied by 11.4 into 10 power 6. And this is 11.8 into 10 power 6. Okay, now last but not least, I will add those two chunks together. So I will have the summation as 34.6 into 10 power 6 millimeter power 4. And then I have Z equal to I neutral axis, which is equal to the summation of IC plus A D square equal to summation II, which is equal to 34.6 into 10 power 6 millimeter power 4. How many agree? Okay. And last but not least, you will say stress is equal to minus mz y over I Z. You have got everything now. If you have to find the maximum stress, you can easily find it. So let me do the maximum stress for you. Unfortunately, I don't have space. That's not good. Hang on with me. Is this clear or not? I thought it was clear. No, yes. Okay. Then last is stress X is equal to, I don't have the mz value, I will give it to you, minus mz. Okay, give me the maximum stress that the object can exhibit divided by Iz. Okay, so give me the y value for maximum stress. This you can find. Come on.
150 minus 53.7.
Okay, he already found. Huh? Let me answer his question. You answered. What was the value you gave?
150 minus 53.25.
Very good. 100.
So it's equal to 96.25.
Okay. Okay, I have for maximum tensile stress, I have negative 118.75. So let's do it together. How can you find the maximum tensile or maximum compressive stress? You have to go from the neutral axis line of the structure to the maximum distance. So if 53.25 is from there, so for my maximum, let's say compressive stress, not 53, I think it's 56. No, I think I wrote the wrong value. 56, I apologize. It's my mistakes, probably. 56 is the value I have in my notes. You have to double check as well. 56.25. And I will also make a correction here, 56.25. Okay.
Also, the values will be changed.
No, values will not change actually. So this value I can help you with it. So 75 plus 25 is 100. 100 minus 56.25 gives me 43.75. Then you can see this distance, it is 25 divided by 2. That is 12.5 millimeter. Now 12.5 millimeter plus, from here to here. So it will be 56.25 minus 12.5. Again, I will get the same value of 43.75. Okay, so let me talk about the distance. So what will be this distance? It is 56.25. So I will have stress X is equal to minus mz into, I am going to the top. So 56.25 millimeter divided by Iz will give me the maximum compressive stress. And then for maximum tensile stress, I will have to find distance from this purple line all the way to the bottom. So if this distance is 56.25 and the total distance from here all the way up to this bottom is 150 plus 25, 175, then 175 minus 56.25 will give me, I don't know, 175 minus 56.25. We have a student who is doing it.
121.25.
118.75, no? Okay, I will tell you again. Do from 175 minus 56.25.
118.75.
Good. 118. So 118.75. It's in the negative direction, right?
Yeah.
So, okay, we have a lot of students who did not understand this, by the way. I have a feeling. No? Yes. So let me make a red line here. So that let's say light blue line. The question ends here. Okay. We are stopping here for 5 minutes. Just tell me if it's clear or not. No, not clear. Confusing? Let me answer this question, then your question. Yes.
The y is confusing by sigma x equals minus mz times y divided by rz. So the y value we found, what can we show is positive or negative?
Yeah, so for
Depends on
example,
the neutral x.
no, purple line, this is my z and my y is pointed upward.
Yes.
So if from the neutral axis you are going up, from the purple line, if you're going up, which is 56.25 in the upward direction,
So it will be positive, right?
56.25 is positive, and your stress x comes out to be negative.
Negative, yes.
But if you are going in the downward direction from the purple line to negative, you will have a negative here and you will get a tensile stress
Yes.
on these edges. I will take your question. Just give me one second.
I was going to ask the same question.
Same question. Okay. Look, this surface will be in tension, right? Look at this, everyone. This one. This one. No, it's clear. Yes, no. Confusing?
Is this because the force is being applied from
Top. I have already explained this part. Okay. So, any more questions in this one? Anyone? Again, it went. I don't know. Okay. So let us proceed then, I suppose.
We also
Uh,
we write reference for the top surface.
no, it is not for the top surface. For the whole thing, you have to come up with a reference line because you want to calculate the y prime, y dash, that is the centroidal line, the neutral axis of the structure. So for that, I have to come up with my own reference line. I made a blue line at the top. If you don't like it, you can make a blue line right at the bottom, or you can come up with any other point for your reference line. Could be at the center, could be at an intermediate point. I made the reference line there because once I have the reference line, only then my y prime, y bar, I apologize, will make sense. Y bar 56.25 millimeter. From where? From the blue line. Okay, on that note, let us proceed. Any questions? Okay. Now, what happens is that, you know, the wood is really good in compression, right? But wood is not good in tension, right? So what happens is we will talk about what is known as composite beam. Yes, please. Okay. That is, if we have two different materials, two different structures that are glued together, and you are utilizing their properties. So for example, if wood is, what did I say, is good in compression, not good in tension. So it makes sense that if I use two different materials, I glue them together and use the whole thing as a beam, then I can utilize their properties to my strength or to my benefit. But the problem is that if you join two different fellows together, then it is very difficult for you to calculate the stresses, right? So right now I will talk about that if you have, let's say, aluminum or some other material joined together with another structure, and you are using both of them as one big beam. Now this is not homogeneous structure. So when you talk about bending stresses, it will be a little complicated as you see this diagram, which I will explain later. So what is the strategy? For composite beams, this will be your strategy. What we will do is, this is elastic modulus 1 of the top one, glued together or joined together, whatever, with the other fellow. What you will do is, in order to calculate the bending stresses, you will actually replace one of them with the other one. So let's say if elastic modulus of the other one, the second one, is greater than the first one, and if I ask you, please replace one of them with the other. Now you have to understand that you are not physically about to replace the whole thing with one. It's just mathematical. So let's say one of the students says, replace the one with the higher elastic modulus. Let's say aluminum or steel, let's say, with the one with the lower elastic modulus. Then what will happen? You have to replace this one with the other one. So you need greater material right here. So that's why you can see I created a big rectangle here. So this will be my new section. And there is another student sitting in our class who said, no, I don't agree with you. Replace the top one with the higher elastic modulus. So his approach or her approach will be, you have to reduce this top one because you are putting higher elastic modulus material. Again, this is hypothetical, this is mathematical. N is equal to E2 over E1. Now for this new section, you will find your neutral axis because you already are super expert, I suppose, by now, how to calculate neutral axis for these sections. Or you can find the neutral axis for this new object and you can proceed. Okay, so this will be the problem we are doing. Any questions? Okay, write down the question. I already explained to you that this problem is not coming in your exam, this one. So you don't need to worry. What I mean is this is not coming in your midterm exam 1. Surely it can appear in your midterm 2 or final, but for midterm 1, I think it is too complicated for you.
So
Yes.
we are going to now figure the first, no,
Yeah, I will explain. So you have to replace one of them. So let's say, just so that all of us are on the same page, otherwise all of us will be doing this problem differently. Let's say we will replace this one. Let's say we will replace the top one. Okay, of course, this is not up to scale, by the way. I cannot do it. It will be super big. And the bottom one remains as it is. There are other students who are about to do it differently, but let's for now do it together.
do we have to stretch it?
Yeah, this is a good question. I understand. Can't we do it? Yeah, we don't. we won't go in that direction. I think the reason of it is probably because we are talking about the bending on the z-axis. So when you are replacing, don't go in that direction. That's a good question, actually. Yeah, don't do that. But we can look into it as well, but we don't go in that direction. Okay, on that note, why don't you help me? So this is your 3-inch. This is my width of, hang on, what is the width? Anyone?
8 inch.
9. Height of 8 inch. Height. So this height is 8 inches. If this is 3 inches, then this total width will be 6 multiplied by 3, right? Why don't you use a calculator and do this for me? 10,200 divided by 1,700. Does it come out to be 18? 6, sorry. So 6 multiplied by 3 is 18, okay? Now that you have got this, let's do this new problem. So what will be your neutral axis? Your neutral axis for the new structure will be somewhere here, right? How many agree? That's how many agree and how many disagree today? This is your neutral axis somewhere, probably, right? Probably. Not sure, but probably. Now this is your section 1. And this is my beautiful section 2. Okay, now give me the y prime. So in y dash, in order to calculate that, I have to come up with a reference line today. So this is my reference line. Now all of you need to calculate y bar. You're not doing this problem. We are not proceeding if you don't give me the y bar. Y bar. Give it a shot. I'm going to do this after 6 seconds. Give it a shot. Y bar equal to, write down the formula for me. Y bar Y bar formula. Summation of YI over summation AI. Y is equal to summation YI over summation AI.
It's about 3.6 inches away from the RF transfer.
It is 3.6.
6.
Good. Very nice. So he did it. So let me do it for all of you as well. This is how he proceeded. I suppose I see one section, section 2. So this is 0.02344. This is 128. This is our D. This is 3.4734. This is 0.6513. Oh, sorry. I have to give you Y bar. Sorry. Okay. I forgot that I am telling you how to calculate that one. 1, 2, then YI, then I have to AI, then YI, AI, and then I have to give you Y bar. YI is 0.25 divided by 2 for first section and 4.25 for the other one. Is this clear to the whole class? Why don't you tell me? Please don't hesitate. Bahadur, 18 multiplied by 0.25. Ghazal has any question? Then you have 24 here. Then we have 0.5625. Then we have 102 here. And as he said, 3.5999, that is 3.6. So students who are getting confused, how did I do 0.25 divided by 2? Because I created my reference line here. So this is 0.25 divided by 2. Then for the other rectangle, this big thing is 8 inches. So that is 4 inches. And from my reference line, it's 4 plus 0.25, that is 4.25. Okay. Now that you have calculated this, you will calculate your IC. This is your D, and this is your II. Let me use a purple color from here. I plus AI DI square. So this is your 1, this is your 2. This one will be 0.02344. This one will be 128. This one will be 3.4734. This one will be 0.6513. And this one will be 51.32. I'm going at sonic speeds, but you can stop me, 138.2. And the combination of them will give me, addition, 189.5 inch power 4. So just tell me if it's clear or not. I don't think it is, so I will explain this. Let me explain everyone because this is not clear. So this is how I proceed. I will say that 3.6 inches from here, 3.5996 inches. If I have to go 3.6 inches from here, then the center of this fellow is sitting at how much? It is sitting at 4.25 inches from this end. So 4.25 minus 3.6 will give me 0.65. So please observe here. I wrote a 0.65. I'm not sure why 13, by the way.
3.5.
Probably. So 0.65 inches. Then I repeat the same process. The center of this rectangle is sitting at 0.25 inches. I'm sorry, 0.125 inches from the top. So I will use 0.125. You can see that I wrote 3 point. Sorry, not from the top. I apologize. So if this is 0.125 from top, so this means from the centroidal line to the center, I will do 4.25 minus 0.125. So 4.25 minus 0.125. Why don't you do this for me? 4.25 minus 0.125. 3. 4.25 minus 0.125.
0.125.
4.25 minus 0.125.
And 4.125.
Oh,
4.125.
so why we have 3.4734 here?
But because we are deducting it from the neutral axis, so 3.6 minus 0.125.
Oh, sorry. Good. Sorry. 3.6 minus. I apologize. Neutral axis is at 3.6. Sorry. 3.6 minus 0.125 gives us 3.4734. Thank you. I was looking at, I'm not sure why was I looking at this one. This is the centroid of this one. We have to look at the neutral axis of the structure. So let me write it down. Yeah. So, okay, yes. So, yeah, it was a mistake. So 3.6 minus 0.125. Okay. Anyways, after doing all of this, you have to finish this by saying stress max is equal to minus mzy over iz. So minus, I will give you the moment. Right now, I don't remember. Multiply by the distance from the neutral axis divided by the iz, that is 189.5 inch. So let's say I'm talking about the maximum. Okay. So whatever this is, give me this is compressive or tensile, we will see. Similarly, okay. What are the two materials, by the way? Did I tell you?
No.
One of them is wood and one of them is aluminum. So this one is the wood. This one is the aluminum. And you can also see the direction of the moment, by the way, everyone. So the moment is like this. So this means the force is acting from the bottom. So this means that the moment is negative direction. So the value of the moment is given to us as mz equal to negative value of 60,000. It's given in the question, 60,000.
Oh.
I will, yes, pound inches. So it is equal to minus 60,000 multiplied by whatever this distance is, which we have to figure out. And you have to give me the maximum value. So give me the maximum compressive stress. You will do it yourself. Now, after finding this distance, give me the maximum stress in the aluminum. So we have maximum stress in the aluminum is negative n times, because we replaced one of them, right? So which one did we replace? I think we replaced the aluminum with the wood, right? So since we have replaced aluminium with the wood, I have to multiply the aluminium with the N divided by IZ, which is equal to N was 6 if you remember. MZ is 60,000. By the way, in an exam setting, most students forget this N. Multiply by the Y that you have to tell me divided by IC. So give me the maximum stress in the aluminum. Now, if it's bending like this, then the aluminum will have maximum tensile stress and the wood will have maximum compressive stress, right? Okay. So give me the value of Y for maximum tensile and maximum compressive. So where is my neutral axis? My neutral axis is this one. So it is 3.6 inches from the top. So for finding the maximum tensile stress on the top surface, I will put a 3.599, that is 6. 3.5999. And here I will put a, I suppose, negative value. So I will go from this yellow line all the way up to the bottom. Okay, that is confusing. 4.25 plus 4 will bring me here. That this is 8.25. 8.25 minus 3.6 will give me distance from neutral axis to the bottom. So 8.25 minus 3.6. Okay, 4.651 is the right answer. Very good comment. So I'm getting a. Is everyone sure that everyone understood this or not? You have to be very.
Sir, I'm confused about the direction of the moment.
I will tell you. No worry. 6837 pound per square inch. This is tensile. Now, this one exists in aluminum. This one exists in wood.
It should be minus 60,000
Huh?
for the compressed version. Because MZ minus that direction. Also, we have minus in formula.
So I put a minus and a minus. Right?
Yeah, if you calculate, we will get positive, but we put minus in blue written part.
Yeah, this one.
Yeah, the whole.
Oh, yeah, this one. Good. Acha, acha. Minus MZ. So minus. Acha, minus. Huh, good. Okay, you are confused in the moment direction. So you can see here.
There's two moments. Like,
No, there is one. There is a moment. There is a moment. There is a moment.
both in the same direction.
No,
No,
you see, look at this hand and look at this hand. So it's like this, right?
Okay.
So it's just a way of expressing.
How is it minus? That's the thing I don't understand.
Because right hand rule, curl the fingers.
It's in the positive x direction.
No. So it's in the negative z. This, you see this one?
Oh, you mean, okay. It's viewed from like the side.
You of course you have to see, of course you have to see like this.
That's what I was confused about.
For find the moment like in opposite one. How the moment in this part.
No, you have to
Try to
you
find
mean this arrow? Forget about it. You have to just curl the fingers of the right hand. Why are you looking at that one?
Yeah, if you do the right hand rule, it will be z direction.
For that one? If you are bending it like this, do I even care about my left hand? No.
You're just looking at.
For sure, I'm just doing like this.
Yeah.
I will forget, I will answer. You have to understand these things. In the last class or class before that, I kept on making arrows of forces, right? And then you used to calculate the moment, oh, moment is acting like this or that. In this question, somebody has given you the moment. I think I posted this notification on O2 class as well. Did I? I think I did. Something to think about. No. Okay, it's 11:30. So I will take your question. We have to go to the next class.
So can you include the answer again for the last?
I will. O2 class. Okay, so on O2 class, did I think I mentioned this. No, this is something to think about torsion. I don't know. I think I did talk about something. Graded homework 7. 1 minute. Look. Look, please read this. In class, we solved problems in which force was applied, and we used to calculate the corresponding moment that was generated by the force. Afterwards, we used to solve the problem. In both the problems shown below, the moment is given. Look, now M is written. Please focus here. Force is not applied towards the left. Force is applied from the bottom. The beam is actually bending like this. That's why the moment is in that direction. So look at this arrow. This one. Do you see this? This one. This means that someone has put the force from the bottom and the whole thing is curling like that. So most of the problems I have done, I think in the class before, I intentionally put arrows of forces so you have a physical understanding. But in your textbook, the guy gives you the direction of M and with a little curly arrow so you can imagine how the force is acting. Yeah, your question. Okay. So, okay, the class is over. I will take his question and we will go to the dynamics class for students. Yes, please.
This question, we found the sigma and found that the looks like 3.6, right? 3.6. I'm going to find it. Yeah, we did the calculation about the sigma and mu maximum. While we find the sigma and mu maximum, why we take this 3.6 here?
Yeah, because the aluminum is the top one and the wood is the bottom one. So if I have to find the maximum stress of aluminum, I will go maximum distance to the aluminum surface from the neutral axis. And the top surface of aluminum is 3.6 inches from the neutral axis.
But also the stress, the pound stress will be give the whole part as I guess, like we found sigma max aluminum, this part, like not aluminum, also we put in the roots.
Exactly. So that's why at the end I had to multiply with the 6 because I said I have been talking about aluminum wood all the time. How can I say that this is aluminum? So I multiplied it with a 6. I will tell you. Look. You see, I replaced the aluminum with lots and lots of wood.
Where's the?
Yeah, like 1 minute. The original structure was this one, but I created this structure, the new one, because I replaced the aluminum and I put lots and lots of wood.
Yes.
The point is that when at the end I am calculating.
This also wood right now, right?
Oh yeah, right now it's wood.
Okay.
So
Why is it 18? Is that
yeah, because the 3 inches is the width, but I multiplied it with a 6 because 6 is the ratio of the elastic modulus of aluminum to the elastic modulus of the wood. So if I'm removing the heavier material and putting a lighter material in place of the heavier material, you will tell me that you have to compensate for the fact that you're putting a lighter material in place of heavier material. So you have to put 6 times more than the heavier material.
So we found the sigma aluminum right now.
Hang on. Yeah. So when I am saying that I have to find the sigma max on the top surface, you have to stop me and say, multiply it with the 6 because you have right now, as we speak, wood all over the place. So that's why it's in that whole chunk. So I multiply it with a 6. Okay. Okay. And if I had replaced this wood with the aluminum. So I have made it inverse. Then
1 over n. Really.
Good, good. So you have to look into an example from book, because it's pretty much like that, that you have to then, I suppose for the other one, you will have to divide with the n. Anyways, yes, please. Any
Hocam,
question?
Also, could you open the hocam grade homework 7? I have a question.
Mehmet'im ben iki tane.
But we have a dynamics class right now, so can we do it afterwards?
Okay,
We have an
hocam, no
office hour
problem,
for this
no
one.
problem.
So I can ask just one
Uh-huh.
quick question. So
Uh-huh.
here, how do we find, why did we use for the maximum compressive 4.651?
Because 4.651 is the distance. So 4.651, if you go from this neutral axis all the way to the bottom, the total distance is
Ah, 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 this
8.25 minus this one will give me
We said this is
distance.
compressive.
So of course, the
Hmm.
other surface will be in compressive.
Suppose when it's like this,
Ah.
the force is being.
I will be very late for the
Okay.
class, so we will talk about afterwards. No worries. Oh, we have dynamics students. Okay, so we are definitely late today.